Good morning. My name is Amy Fuchsteiner, your instructor for elementary algebra. We're going to begin with Chapter 1, Section 1, which is about just the language of algebra. We're going to start with this idea of reading your tables and your graphs and some of the basics. So here we have a graph. We have the horizontal axis, which shows you the age of the machinery in years. We have the vertical axis, which shows you the value of the machinery in thousands. If you follow along the horizontal axis to the number of approximately 15 years, you can then follow that blue line up to the point on the line associated with the age of 15. And you can follow the second blue line across to see that is approximately $35,000. So this tells us that the age of the machinery at 15 years is $35,000. This gives us a point of reference so that we know 15 years is $35,000. If we were to go further down the horizontal axis to 30 years, we would follow that up to the point on the line, which is associated with $20,000. So we see that at 30 years, this particular piece of machinery is worth $20,000. So as the horizontal increases, or moves up from 15 to 30 to 60 years, the value of that machinery decreases or becomes less. This is known as a depreciation. So when you're looking at a graph, are you able to read it, whether it is a line chart, as this one is here, or a bar chart? The second goal of this particular section is to introduce you to the vocabulary of algebra. We have here a listing of vocabulary words that we're going to ask you to be familiar with. The first four are the sum, product, quotient, and difference. Each one of these represents the answer to a different operation. The first one, sum, is the answer to addition. The second one, product, is the answer to multiplication. Quotient is the answer to division. Difference is the answer to subtraction. So I could ask a question like, what two numbers have a sum of 10? There is not just one answer to this question. That could be 1 added to 9, 3 added to 7, 0.5 added to 9.5. It's simply telling me that 10 is the answer to that addition problem. Product is the answer to multiplication. So if we ask you what numbers have a product of 20, I'm asking you what numbers, when multiplied together, will have a product of 20. What numbers will have a quotient of 6 or a difference of 2? Each one of these references a different number. All right? I wanted to take a quick minute here and remind you of some of the notations as well. If we're talking about a sum, that notation is a plus sign. If we're talking about a product, the notation for multiplication is either a dot, a multiplication sign, or parentheses. Those are the three most common. For quotient, the most common references for division are the actual division symbol, the box that you used in grade school, and the fraction bar. For difference, that is subtraction, and we simply use the subtraction sign. So those are your different notations. Algebraically, we have 4 words here that you may or may not be familiar with. The first is the idea of a term. A term is a combination of letters and numbers held together by multiplication and division. Now, terms are made up usually of 2 different parts. The first part is the variable. The variable is a letter that holds an unknown value. The coefficient is the multiplier of that letter, or the multiplier of a variable. The constant is just a number, and the value is known. What do I mean by that? Well, to put it simply, it's a 4. How much is a 4 worth? 4. So if you had 4x, this is a variable term because it has a letter in it with a coefficient of 4. 12 is a constant term. It is always worth 12. So a variable term will have a variable in it, such as 4x has a variable of x. And then it will also have a coefficient, in this case, 4. Now, not always is the coefficient written. Sometimes you will see something like, I'm writing down the side here. Sometimes you will see, let's say 1m, that's the same as m. In either case, this is a variable term. The coefficient is 1, the variable is m. Right? What is the difference between an expression and an equation? Well, an expression, where did it go? All right, algebraic expressions are when you combine different terms with operators. That is addition, subtraction, multiplication, division. An equation happens when you set expressions equal to a known value, or in some cases, another expression. For example, if you have, let's say 4x plus 12. This is an expression. It is not set equal to anything. We do not have a known value associated with it. So 4x plus 12 is a combination of a constant term, a variable term, and the operator addition. It is not set equal to anything. So it would not be given the definition of an equation. In order to be an equation, we have to set the expression equal to something. So if I had 4x plus 12 and I set that equal to a 20, now it is an equation. Put simply, equations have equal signs. Expressions do not. It is also worth noting that expressions can only be simplified. Equations can be solved. In other words, I can't tell you what x is in the expression, because whatever x is will give me a different value. If x is 1, I will get a different value than if x is 5. However, in the equation, I can solve the mystery of how much x is worth, because I know 4x plus 12 has to be the same as 20. So the equation can be solved. The expression can only be simplified. The third goal in section 1.1 is to identify the equations and expressions in the language of algebra. So the idea here is that when you are given a problem or a mathematical statement, such as listed in this first one, can you say this or write this using language? So ideally, what we would do is use some of the words that we just went over. This is an equation, and we have an 11 minus 5 and a 6. So it is acceptable to say that this is, in a language, 11 minus 5 is equal to 6. However, if we're going to use the words we just learned, such as sum, quotient, product, and difference, this says that 11 minus 5 is 6, or 6 is the difference of 11 and 5. 6 is the difference of 11 and 5. Similarly, in the next one, we have equal to 18. Now, we're doing 2 and n, so those with no sign between them is multiplication. I should add that back in. One of the signs of multiplication is that there is no sign. So we would say this one as 18 is the product of 2 and a number. Remember, n is a variable. It's a letter holding the spot of an unknown value. That value is some unknown number. So 18 is the product of 2 and some unknown number, or 2 and a number. In the third example, we don't have an equal sign. That means that this is not an equation, but rather an expression. Since it is division, and our word for the answer to division is quotient. So what we're looking for here is the quotient of 66 and 6. The quotient of 66 and 6. Notice I'm not telling you what it is because I don't have an equal sign. And without an equal sign, I'm not going to go ahead and put in what it is equal to. Can I find what it is equal to? Sure, I can do 66 divided by 6. I know what that answer is, but without the equal sign here, I'm not expected to translate that part or simplify it Because there's no equal sign, I would not solve this answer. I would only simplify it if I can. The fourth example here is one of an expression that cannot be simplified. We have done as much as we can. We have addition, and in our algebra words, this is the sum. Sum is our answer to addition. This is the sum of what are we adding together? 12 and some number. We have called it x here, but it really is just an unknown number. All right. You will also be expected to do this with the language of the actual sentences. The sale price is $40. This should read off of the discount. So the sale price is $40 off of the discount. You see the word is. Because is in there, I know there is an equal sign. The sale price is or equals $40 off of the discount. The sale price. I don't know what the sale price is. I don't know what the sale price is. So I'm just going to use a P for that sale price. It's not known. If you wanted to use an X, use an X. That's fine. Any letter will hold the place. Now, $40 off of the discount. Think about that one for a minute. $40 off means I'm doing the discount and then I'm taking off or minusing $40. So I've got to do the discount. So I have to do the discount minus $40. So the discount is not known to me. I'm going to do this as D minus 40. And I have translated the sale price is $40 off of the discount to P for price is equal to discount minus 40. All right, last example in this section. 7 times the age of a dog does not give the dog's equivalent human age. Does not give is my verb in this sentence. 7 times the age of a dog does not give the dog's equivalent. And because that is my verb, that is the stand-in for the equal sign. Except I was a little bit tricky here because it does not give, which means it would not be equal. So it's not an equal, it's an inequality. It's not equal. 7 times the age of the dog would be 7 times D. Remember, if you're multiplying, you can use the multiplication symbol, or you can just write it as 7 times D, 7D. The dog's equivalent human age, and I'm going to use an H for the human age. So 7D does not equal the H. The fourth goal in this particular section is that you are able to use the formula to fill in tables, and likewise, you're able to use a filled-in table to discover a formula. So here I have P is equal to 150 plus M. The table tells me my varying values of M. So for the first one, I'm going to say P is equal to 150 plus, for the first time through, my M is 50. So 150 plus 50 for trial 1. And that's going to be 200. So when M is equal to 50, P is 200. Likewise, for the second trial, I'm going to see what happens when M is 100. So P would equal 150, that part stays the same, plus 100, which is 250. For the third trial, we said P is 150 plus, and I'm going to put this 150 in for that M. So I'm going to have 150 plus another 150, and that's going to be 300. So my 3 answers here are 200, 250, and 300. And I was able to fill in the table to get the different data. The last example Notice I know that M is equal to F over some unknown question mark. This is what we're going to find. We're going to expect to find this, right? That's my formula. So what do I have here? Well, I know that when M is 24, this is going to equal 36 over something. I don't know what. So 36 divided by what gives me 24? 34 gives me 51 over something. And 12 comes from 18 over something. Well, since these are division, I want to undo the division, right? I want to figure out, what does this equal? Well, 24 multiplied by whatever that is have to give me 36. Would you agree? 24 times some number has to be 36. 34 times that same number has to be 51. And 12 times that number has to be 18. So how do we figure that out? Well, a couple of things. I know 24 times 1 is just going to give me 24, right? And that's too small. I need 36. I know 24 times 2 gets me 48. I needed 36. So it's somewhere between 1 and 2. At this point in this course, we are not solving things yet. I haven't done all the algebra with you. Maybe you already know some of that and this is a review. That's fine. But if you don't know the algebra, you can guess and check it, right? 24 times 1 is 24. 24 times 2 is 48. So I know if I'm going to try and get a 36, the number I'm using has to be between a 1 and a 2. So I'm going to try 1.5. I know the number I want to use has to be between a 1 and a 2. So I'm going to try 1.5. To do that, I'm going to grab my calculator over here, and I'm going to do 24 times 1.5. I'm just guessing at this right now. Ooh, and look at that. I do get a 36. Now, if 1.5 is the right answer, then 34 times 1.5 should be 51. And 12 times the 1.5 should be 18. Since it works for all three, I know that this formula was meant to be M is equal to F over 1.5. And I can answer that question as to what's missing from the formula. All right. So we have covered the 4 goals for this section. We've read through some tables and graphs. We've talked about the beginning vocabulary for algebra. We've looked at some of the language translations, and we've used some formulas to fill in tables. If you have any questions about this information, please let me know. There are additional resources available in your textbook and in the WebAssign program under resources for the course. Let me know if you need anything. Thanks. See you next time.